Okay, we're looking at question 12 here. We want to use the Bohr equation to calculate the energy. I'm going to go ahead and write the Bohr equation on the page here. So that is delta E equals negative 2.18 times 10 to the negative 18th joules. And then we have two different n's here. That came off of our periodic table. And it's final and initial. But how this question's worded, we wouldn't necessarily know which one is final and which one's initial, because it just wants a large jump, largest energy absorption, involving the n equals 2 state. Alright, now since it's wanting a large drop, there's actually two potential ways we could look at this. Now what I wanted to get at is we have our ground state, which is n equals 1, and then the state we're looking at is n equals 2. But I want you to remember how Bohr actually showed these levels get closer together as we go up. So the large jump is almost always a step down. But the other possibility is actually going up here to an n equals infinity, where it's ionizing. Right, but we can actually kind of figure out which one is likely just by plugging in some potential values. So if I assume it's this lower one, I'll just label it A, then I'm going to have, let's see, it's going to start at the n equals 2 and go to n equals 1. So we'd have 1 minus 1/4, so that would work out to be 0.75. I'm going to write that right there, because what I'm going to do right up here is we're going to do the exact opposite. So I'm going to have the final being the infinity, where it leaves, and therefore the initial is that 2, which would make this 0.25, because 1/4 minus 0. Because of that, we see that the most energetic or largest jump is this guy, where n is going from 2 to 1. So I'm going to calculate what I get when I multiply that by that 10 to the, or 2.18 times 10 to the 18th. But what I'm going to do is I'm going to put the values in here for that jump, which matches up here. Oh, got my calculator on here. So negative 2.18 times 10 to the negative 18th times, in parentheses, 1 minus 1/4. And I get, and since it's a delta E, I'm going to put in this as a positive value. So my delta E, I didn't give myself enough room there. My delta E for that case is 1.64 times 10 to the negative 18th joules.